Okay guys, this is concept 67, proving trig identities. In this one, we're going to be proving or verifying an identity means to show that both sides of the equation are the same. To prove an identity, simplify one side of the equation until it is equal to the other side of the equation. A hint here is work with the side that looks more complicated. Okay, so looking at this first one, here's the equal sign. Okay, obviously the left side looks more complicated than the right side, so we're going to take this advice and work with the left side. We're going to simplify it. Okay, simplify as in like, yes, the previous concept, until it looks like cosecant theta, until it becomes cosecant theta, in other words. Okay, so first one, cosine theta is going to become 1 over sine theta. Okay, I have cosine squared theta. I'm not going to change that one. And then I have plus sine theta. I won't change this one either. And then I know this needs to look like cosecant theta, so I only changed the first one here. Okay, alright. Multiply these two. I'm going to have cosecant squared theta over sine theta. Okay, plus sine theta equals cosecant theta. This one, I could say it's like sine theta over 1. I have two fractions being added. I need like denominators, so I'm going to multiply top and bottom here by sine theta, because I need sine theta in the denominator. Okay, right here. So this will become cosine squared theta over sine theta plus sine squared theta, sine theta times sine theta, sine squared theta, over sine theta, and that's equal to cosecant theta. There. Now I have two fractions with the same denominator. I can combine them. So then I'll have cosine squared theta plus sine squared theta all over sine theta, and that's equal to cosecant theta. Cosine squared theta plus sine squared theta, that's an identity. Okay, that's equal to 1. So then on the left side here, I'm going to have 1 over sine theta is equal to cosecant theta. And then, oops, this right here, 1 over sine theta, that's the reciprocal of cosecant theta. And there. So then cosecant theta is equal to cosecant theta. Okay. That's what I'll be looking for. This includes a test as well, that all the work here makes sense, okay, leading up to the identity. For number 2, I guess you might argue that both sides look complicated. I'm just going to go ahead and tackle the left side here because it's sine and cosine. It's something that I'm more familiar with working with. So I'm going to try to make this side look like the right side. Okay. Let me see. I need secant theta, I need cosine y, and right here I have a cosine y in the denominator. So what I'm going to do then is I'm going to apply an identity here. Okay, sine squared y. That one is equal to 1 minus cosine squared y. Okay, that's an identity over, let's have the cosine y. That's equal to secant y minus cosine y. Now, I'm going to take this fraction here and I'm going to split it up into two fractions. Because I have two terms in the numerator, I can split it up into two fractions. Just like right here, I combine them, cosine squared theta plus sine squared theta, they're both over sine, and I merge them into one fraction. I can work backwards and have two fractions. Okay, so that means here I'm going to have 1 over cosine y minus cosine squared y over cosine y. Okay, those are the two fractions, equals secant y minus cosine y. 1 over cosine y That's the reciprocal of secant y. For the next fraction here, I have cosine squared y, cosine y. Those cancel there, so I'm left with just cosine y. And there. That looks like the right side now. Done. Okay. Looking at 3, I have cosine squared alpha is equal to sine squared alpha times cosecant squared alpha minus sine squared alpha. Obviously, the right side here is the one that looks more complicated, so I'm gonna have to make this equal cosine squared alpha. So I'll have sine squared alpha. I'm not gonna change the first one. Cosecant squared alpha, that would be 1 over sine squared alpha minus sine squared alpha. Okay, these two here are being multiplied, so then when I apply the identity, this is being multiplied here, and your properties here of fractions, those are going to cancel. So then you're left with just 1 minus sine squared alpha. Okay, and then, oops, I forgot to put my cosine squared alpha there. Okay, 1 minus sine squared alpha, this is an identity, right? It's a Pythagorean identity. That's equal to cosine squared alpha. And there. Now they both are the same. Okay, going to 4, tangent x times x is equal to cosine x. Clearly, left side here is the complicated one. So what I'll do is I'm gonna distribute, let's see, maybe the best way to go about this one. So what I'm thinking here, and is to help also your thinking process for those of you that have a hard time to start some of these, I can probably either distribute the tangent x in, or I can combine these two fractions first inside and then go from there. I'm gonna distribute tangent x in first. So here's what I'm thinking. Pink. And let's hope that this is the easy method. I mean, I don't know. Maybe it is, maybe it isn't. So I'll have tangent x times secant x over tangent x minus, okay, this distributes to both, so then tangent x times tangent x over secant x. That's all equals. For this first fraction, these guys are going to cancel. So then I'm left with just secant x minus tangent. So tangent x times this, I'm going to have tangent squared x over, you could probably hear the freeway and I apologize if you can hear the cars out there. Tangent squared x over secant x, that should equal cosine x. So then to combine these two, I could say this is like secant x over 1. So to combine these two fractions, I need like denominators. So I'm going to multiply the first one by secant x. Okay, that'll give me secant squared x over secant x minus tangent squared x over secant x. Is that equal to cosine x? Maybe. Two fractions now have the same denominator, so I can do secant squared x minus tangent squared x over secant x. That's equal to cosine x. Secant squared x minus tangent squared x. This guy right here is an identity. Okay, that's 1. So then I'll have 1 over secant x is equal to cosine x. And then I know 1 over secant x, that's the reciprocal of cosine x. So then these two sides are the same. Number 5, I have cotangent squared theta is equal to cosecant squared theta minus cosecant squared theta times sine squared theta. I'm going to work with the right side. That's the more complicated one. So then cotangent squared theta should be equal to reciprocal identity of cosecant squared theta is 1 over sine squared theta minus, again, 1 over sine squared theta times sine squared theta. Okay, these guys cancel out. So then I'm going to have cotangent squared theta is equal to 1 over sine squared theta minus 1. Let's see. Cotangent squared theta is equal to this. I'm thinking, this is probably not going to get me very far. Yeah, let's combine these two then. I have this fraction minus a whole number. That's like having 1 over 1. So then, to combine them, I'll have to multiply the second one, the 1, by sine squared theta. That'll give me cotangent squared theta is equal to 1 over sine squared theta minus sine squared theta over sine squared theta, and there you go, I see it now. Okay, these two fractions they have the same denominator, so then I'll have 1 minus sine squared theta over sine squared theta. 1 minus sine squared theta, that's an identity. That is cosine squared theta over sine squared theta. There you go. This right here, that's I'm drawing a blank here, a quotient identity. That's cotangent. Cotangent squared theta is therefore equal to cotangent squared theta. Okay, skip 6. We're not gonna do problems like this. These do take what were they called? The even odd identities, but we're not going to worry about these type of problems. Okay, on the page. So for number 7, we have 1 plus sine squared theta is equal to 1 plus cosecant theta over 1 plus cotangent squared theta. Right side is the more complicated one. So then, let's see. Here's what I'll do. That is equal to 1 plus cosecant squared theta. I'll apply the reciprocal identity. So this cosecant squared theta became 1 over sine squared theta, and then for the bottom here I'm going to have 1 plus cotangent squared theta, that is cosine squared theta over sine squared theta. Okay, now in the next line I'm going to combine the whole number with the fraction. So again, it's like having 1 over 1 there for both the numerator and the denominator. I'm going to have to multiply by sine squared theta. That'll allow me to combine them. So here's the left side. 1 plus sine squared theta is equal to sine squared theta over sine squared theta plus 1 over sine squared theta Again, this one is what happened here. This one, I just brought it down here. Now I'll write this one out. This gives me sine squared theta over sine squared theta plus cosine squared theta over sine squared theta. Now I have two sets of fractions here, same denominators, right? So I can combine them. So I'll move up here. I'm going to have sine squared theta plus 1 over sine squared theta all over sine squared theta plus cosine squared theta over sine squared theta. Okay, so whoops, and I forgot my left side, right? Here's the left side, so that's equal to 1 plus sine squared theta. I still have him there. Okay, for the right side then, there's my left side. Here's a complex fraction. Okay, this, hang on, I think it froze. Did it freeze? I'm not sure. There it is. Okay, this divided by this. Divide by a fraction, multiply reciprocal. Sine squared theta plus 1 over sine squared theta times sine squared theta over sine squared theta plus cosine squared theta. So then these guys cancel. Not only that, this guy is an identity. I didn't even pick him up, he was right there too. Okay, he's an identity. Same right here. Okay, this is equal to 1. Okay, so then it's just 1 here. 1 plus sine squared theta is equal to then, well then these guys canceled. It'll be this times 1, right? Which is just that then. Sine squared theta plus 1. Okay, and yes, these are the same. Okay, a plus b is the same thing as b plus a. Okay, that doesn't change. The order here doesn't change, so these are the same. Okay, let's look at 8. I'm gonna go ahead and work with the right side again. So I have sine u plus cosine u is equal to secant u plus cosecant u. Let's see. No, sorry, I read the wrong line here. Sorry. Yeah, no, this is right. Secant u plus cosecant u. Okay, this will be 1 over cosine u plus cosecant u. That'll be 1 over sine u all over tangent u. That's sine u over cosine u plus cosine u over sine u, because that's cotangent u. Okay, so I replaced all 4 here with either a reciprocal identity or a quotient identity. So then my next step will be to combine both sets of fractions, just like we did up on the previous example. I have cosine u, sine u, so then I'll have to multiply each one by each other's denominator. So it's going to be very tedious. This will be sine u plus cosine u is equal to sine u over sine u cosine u. So this guy right here is this guy plus this guy right here will become cosine u over sine u cosine u all over this guy now will become sine squared u over sine u cosine u, plus this guy here will become cosine squared u over sine u cosine u. Okay. Moving here, I have the left side, sine u plus cosine u, sine u plus cosine u will become, that's equal to, right here on the right side I have sine u plus cosine u all over sine u cosine u over sine squared u plus cosine squared u over sine u cosine u. This right here is an identity that's equal to 1, and one has space. You have a fraction over a fraction, divide by fraction, multiply reciprocal, so then I'm going to have sine u plus cosine u over sine u cosine u, so that's this top one, okay, times reciprocal of the bottom, sine u cosine u over 1, because this guy here became 1. Notice then these guys will cancel, and so you're going to have sine u plus cosine u is equal to sine u plus cosine u. There you go. Got them to be the same. Okay. Let's see.